Greetings. Thank you for having me for the Pedagogy 2025 conference, Emerging Theories, Teaching, and Technologies. I am Dr. James Hutson from Lindenwood University. I am Department Head of Art History, AI, and Visual Culture. I'll be presenting today on an assignment that we designed, Beyond Code, for this presentation, Human-Centered AI and the Dissolution of the STEM Humanities Divide. Now, the context that we have here for why we're approaching and bridging art history and, say, AI, machine learning algorithms, ArcGIS, and story maps is that the digital humanities are now kind of emerging and looking outward, right? We have the public humanities. We need to engage external stakeholders in order to demonstrate value and how these methodologies we've been using in the humanities can pair quite nicely with the new tools coming out, which are lowering the barrier to entry for coding projects and programming. So focusing instead of lecture-based classes and those that are merely going to be knowledge acquisition, really looking at student-focused PBL or problem-based learning courses. And so this is one of those examples we'll talk about here, which is going to connect the coursework to authentic contexts, right? So how does this apply in the real world? We get asked this all the time, and this answers that question. So we're no longer bound by the teaching styles of the past, in which we can now focus on real-world projects, given the technologies make knowledge acquisition so much faster, and one can upskill in areas that they were not familiar with much more rapidly now, thanks to AI skill building, which is what we build into this class, as we'll discuss. As well, we have interdisciplinary collaborations, so we need to work with those in other areas such as human geography, GIS, right, computer science, etc. And so doing this as well as partnering with industry, in the example we'll give here today, is going to showcase the rich legacy and relevance of the humanities and really moving beyond the silo of what is possible. As you can see here, in this particular image, my colleague, Professor Joe Weber, is doing a photogrammetric scan of Santi Apostoli in Florence, right, showcasing and bridging the art history as well as the technical side of capturing these with geometric accuracy for future study as well. So this as well is going to kind of balance out the notion that technology is going to solve all problems with the notion that we have to embed social responsibility into the curriculum. And there are those stop gaps and those measures placed in this assignment. This builds upon a lot of the research that we've been doing for the past 5 years associated with the confluence of AI, art history and digital cultural heritage, right, and the arts, right, so really XR as well. I set up an XR lab here at Lindenwood University. So the most recent book published is going to be Beyond Code, right, so eponymously named for this presentation as well, where me and my colleague, Dr. Dan Plate, looked at the application of low-code, no-code tools across humanities disciplines, right? Showcasing that programming and coding is no longer the sole area and domain of computer science. We can now take advantage of that with our students as well. So the digital tools, right, that we're going to be looking at for this specific assignment are specifically low code, no code. That being, they don't have to be able to code in Python or JavaScript or HTML. They learn along the way, thanks to various AI tools, how to get the coding that they need in this way, which really is going to democratize computational thinking in that you lower the barrier to entry. And so students in history, art history, or other humanities disciplines can no longer state that they're not a coder, they're not a programmer, they can't take advantage of those tools, because now they can. So for this one, we're going to be looking at spreadsheets and timeline.js, in which we're going to organize and analyze the humanities data sets without coding in this way, so that we can put forth chronologies right in our archival data. We're also going to use story maps in ArcGIS, which is a very friendly drag and drop interface that students can use even in K through 12 environments in this way, and also helps them understand many STEM related kind of activities. But this combines, once again, geographic mapping with text and media to create interacting narratives, right? So this is going to help us in telling stories, and that's what we're really trying to help them do here, is understand how to tell stories with data, with numbers. Right, so which is something that we don't often cover in the humanities, right? We stick instead with qualitative interpretations, right, of human expression very often. So in this example, we're going to have open data repositories. So they're going to be using public domain information that is publicly available, so we don't have to worry about additional ethical quandaries and or IPP. So this is going to provide transparent source data sets so that we can then create things like looking at vacancy and code violation registries. And then finally, agentic assistance, or they can be just simply any of the LLMs or large language models that we have, because they do have agent mode built in now, in which they can, of course, generate prompt guides in the workflows. So working through multiple steps. So instead of just, say, output this text or output this line of code, you can tell it to go in and code and create, right, a website for this data that I've curated, access the ArcGIS account that we have logged in, and then source this data and combine it, right? So there can be multiple steps in the workflow that students can now take advantage of. They just need to know the steps and how to problem solve, and that is really what we're looking at moving forward, is training a generation of problem solvers. So these are no-code tools, right? So many of them that you're familiar with. Base 44 is one of the most popular ones for creating apps completely through natural language, right? Replit, right? Ghostwriter, GitHub Copilot, right? All of these are going to be low-code, no-code options for vibe coding as well. Lovable's another example. And then, of course, story maps, tried and true tool that's been used, once again, for decades for teaching GIS and geography. And then other open data, right? So that's what we're going to be using for this assignment. Now, the approaches that's taken here is not lecturing in a classroom, but instead the flipped model, in which they gain the information outside of the classroom, upskill, look at the information, the training, and then come in and discuss, right, in class how things are going, collaborate with one another, and really focus on problem solving in this way, working in groups. So in this way, we're trying to educate the whole person, right? Not just the technical skills, not just thinking about social responsibility and ethics, right, but kind of emphasizing AI literacy, or more importantly, AI fluency. Literacy being understanding how the technology works, and then fluency being how to use it and engage with it. So this is going to be AI-enhanced art history education we've been looking at, right, so in which we're going to be using these coding tools to boost engagement and to give them additional, right, self-efficacy without, once again, increasing cognitive load, in which if you were teaching coding in the traditional fashion, that's all we would be able to do the entire term. Okay, moving to the next one. Here we go. So the tools and platforms, again, we had the visual workflow builders that we're going to use, OCR, which is now built into nearly every LLM, including ChatGPT, to do, of course, transcription, converting images into readable text, right, describing them, agentic assistance, and then photogrammetric tools such as Matterport systems, right, systems that are going to handle the scanning 360 degrees and the combination of millions of images, piecing it together into an environment you can walk through virtually. So the assignment we have here is going to be a historic preservation brief. Relatively straightforward. This doesn't need to be a capstone assignment. And it's designed in order to guide students to creating their preservation brief in ArcGIS story map, right? Addressing a real world site and problem. So this helps them practice human-centered AI skills, right? Using these no-code tools, using transparent and ethical workflows, and community partnerships, working with those in the community to identify what needs to be done. By doing so, students are going to be connecting data analysis with the storytelling and understanding civic relevance of what they're doing as well, demonstrating they can trace provenance, right, and use tools responsibly. Now, the timeline for the class, you have the first section is really the flipped classroom model leading up to it, and then we have the applied section, the second half of the class, in which you're going to be scoping. They divide into teams. We then have them go find the site that they wish to work on. They do data discovery. They do research and finding maps and doing OCR. We'll go through each one of these steps, right? So finally ending with a type of partner critique and revising what they're doing. So the first step that students do is, of course, scoping, right? So that being they choose a building or a block that needs preservation. We, of course, are here in St. Charles, Missouri, the first capital of the state of Missouri, which is quite old, right? So founded back in the 18th century. And so we have plenty of historic structures. So we frame with the guiding question, of course, which structures face the highest risk maintenance and what has the most need at the moment. So then we have to identify stakeholders, right? Is there a city office they need to contact? Is there a neighborhood, right? A nonprofit group, right? They need to be working with. And then defining what success looks like. Is it going to be a brief outlining what needs to be done, identifying costs associated with it, materials, what historical steps would need to be taken if it's an historic site, for instance. So you cannot modify historical structures without going through the historical society here. Now, this is where external partners comes in, right? So you're going to have, obviously, the university, where we are, your community groups, right? So your historical societies, your civic, we have the city of St. Charles, the county of St. Charles, and then, of course, you know, your industry or nonprofits interested in preserving, such as Historic Main Street here. So this is how we're going to be engaging with the public, and so they understand not only civic engagement and the significance of what they're doing, but also practicing those much needed power skills, those transferable skills, that being going out and learning to communicate, to work in a team with other students, to engage with other partners, right? To collaborate, to problem solve, to think critically and creatively. These are the most valuable skills now in the age of AI. So the next part is going to be discover and the acquisition of data. So the instructions they have is to find an open data portal, such as a municipal portal. Here's one in St. Louis with regional data. This one for St. Charles County, which has open data sets and parcels that they can download, right? So they don't have to worry about any proprietary information, right? That's going to be copyrighted or otherwise. So they then are going to record where they found it, the access dates, learn how to trace, right, their process. Next, they're going to consider the risks and mitigation factors. So as far as the data that they're collecting and how they're collecting it. So are there privacy concerns? In this case, of course, we're ensuring that they're using open data sources and readily available ones publicly. So we avoid that, but make them aware that's going to be a problem. Obviously, bias in terms of the data itself, and once again, the students interpreting the data, as well as the quality of data, right? So we track it on this type of graph, right? So an XY graph in order to understand where that would fall, so they know the likelihood of failure in this particular example, such as something that's overly biased, or they don't have the tools to use it, or they don't have enough timeline, etc. Right, so step 3 after this is going to be digitizing the archival sources. So they gather inspection cards, permits, and maps, such as what you have here, an historical map of St. Charles. They use OCR, right? So they can use specialized software, or they can just use something like Claude or ChatGPT, which does have OCR built in, right? So they then are going to save, and this is what it looks like down here through JavaScript once OCR is finished, you know, a map of the city of St. Charles compiled from official surveys, April 1900, right? So it's going through and making it readable text. So they then save that in the raw version and note what was corrected. Next, they're going to clean, reconcile, and geocode the data. So they learn how to track and keep records. So they create spreadsheets here, standardizing columns as far as address, the year they were built, the condition of the structure, etc. And then reconcile any inconsistencies associated with it, and then geocode each address as you see here. And all of this is going to be logged, right, in order to ensure that we have the data cleaning record for this assignment. Next, they're going to integrate and build a conditional index here. So the conditional index is going to use simple weights. That's going to be joining parcels, inspection, vacancy data into a table, right? So they're going to have a weighted score that would be appropriate, such as 40%, right, for violations as an example. You normalize these scores to a consistent 0 to 100 scale, right? So obviously we want to make sure through data literacy that they understand to always start at 0 when representing data. All of these are going to be kept on formulas visible in an appendix that they turn in at the end of the assignment. Next, they're going to document the site, right? So now they've gone through the records, they've done their research, they have mocked up all of the data that they could find historically. Now they go to the site and actually photograph it, capture it. If we have enough time and there are few teams, say if there are only 3 teams, then we can break up use of our Matterport system whereby they can make an interior and exterior scan, such as the dollhouse you see in the lower image here. In which they can then move through the structure, thus better able to identify any cracks, openings, water issues, right, and pinpointing more carefully and explicitly what changes and what repairs need to happen. Next, they're going to record the provenance and the risk. So they maintain a provenance log for all the data that they're going to be looking at, specifically asking questions of the who, what, when, and why, right, associated with the provenance of how the data is collected, the history of the structure, and identifying and assessing potential risks, right? So obviously ensuring the data is high quality, ensuring again that they're taught to look out for bias in the data, and ensure, of course, that privacy is maintained. They then create a simple risk register, right, in 3 columns as you see here, broken into issue, likelihood, and mitigation. So is there a crack in the foundation? What is the likelihood that will lead to a structural failure? What type of mitigation is necessary for that, as an example? So this allows them to build the spatial narrative next, right? So they have the imagery, they have the scan, they have photographs, etc. They have the maps, they've done OCR and have the readable text, right? So they can create then the ArcGIS story map that they started with and familiarizing themselves with at the first part of the class with the software. So they then begin with the site history. So when was it built? Who was it built by? What was it for? And then show the conditional analysis and their key findings of what would need to happen to preserve the structure and what the timeline would be. And this is where you also embed the provenance link for transparency, showing all the work that they did so they can be retraced. So the next step is going to be writing out this preservation brief through this type of spatial narrative here, in which you're going to have the instructions. This is their final brief that they write out, which is a draft of 4 to 6 pages, including their executive summary, as you see here, with the scope, their findings, their impact, the building condition and risk overview, right, and their prioritized interventions and cost bands, as you see down here. That being ranked into priority for high, medium, and low for the interventions such as roof repair, medium being facade cleaning and mortar repointing, and then finally tuck pointing, for instance. And then finally, you know, the low would be like window frame repairing. That's not really going to damage the infrastructure. So all of this is supposed to be written in professional but plain language, so they have a record of how to do this professionally. And then, of course, they're going to self-assess, and they've had this rubric from the outset, which is aligned with the AAC and U value rubrics, NACE career competencies, and these kind of provenance records. So they're going to submit 3 files: their story map link, their preservation brief as a PDF, and the provenance risk appendix that they were putting together. They'll write a short reflection paper explaining what worked and what could have been improved, and what types of power skills they developed along the way. And then they're going to be able to use the provided rubric to double check themselves, right, as they are moving along, as far as the quality of their provenance recording, interpretability, the spatial narrative that they created, and so on. So what this gives us now is the ability to bridge the gap between STEM and the humanities. We are now able to take the valuable methodologies and approaches of both sides and really move past, right, the silo that has divided each. What we didn't mention in the presentation here is that students who might not be familiar with some of the terminologies or processes are provided with a GPT, their own trainer, their own teacher, which goes through and teaches them each one of these sections. Thereby, they learn how to create their own tutors, their own teachers. So when they go out and encounter new things they're unfamiliar with, they will know how to adapt, learn those skills, and apply them. Here are the references from the most up-to-date that we have here from the National Institute and Standards of Technology, National Park Services, and so on. And if you have any questions, feel free to reach out, right? My contact information here at jhutson@lindenwood.edu, and enjoy the rest of your conference.